cue house lights. Oh, look at that, see? It's bright and it looks lovely. So that means that's our cue to start. So let's do it. Hello, everybody. Hope you're all well and that you've been enjoying the festival and you've taken part in a few of the events and had some fun. So here we are. We're here to have our actual final of these One World talks, or discussions in this case, panel discussions. And we're going to meet our fantastic panel in just a moment. But I'll just start with the COVID health and safety, which is that you'll see that we're not wearing face coverings on the panel, but that is because we're not facing each other and we're a metre apart, and we had them on in the green room and then we put our masks back on to go back out again. But we would like you to keep yours on, so thank you for those of you. It looks like pretty much all of you are wearing them, and we really appreciate that if you keep them on during the session. But if you think I'm being hypocritical, it's just, you know, we're taking our precautions up here, but we really appreciate you doing your part as well. So this is, as I say, it's part of the One World series here as part of the Great Exhibition Road Festival. And the festival's not just running today, it's running right up into the week ahead. And there are plenty more talks, performance, discussions, demonstrations, lots of fun stuff, and we really want you to take part in them as well. So I guess some of you will be back to studying or back to work in the week ahead, but you can always take a bit of time off to come and indulge in what we're doing here, both in real life, but also online. Speaking of online, we've got an online audience as well, so hello to them. Thank you very much for joining us online, and if you have any questions, just type them into the chat, and they'll come up on my iPad over here. But if they're rude or abusive, they won't, because they get moderated. But if they're nice ones, and good ones, then we'll get through, and I will get as many in as I can. And for you, dear audience here as well, if you've gone to all the trouble of coming, then we've given you a microphone to pose your question at the front. So that's all jolly good. So really the theme in this final of our talks this afternoon is all about kind of making stuff greener. So what do we mean by that? You know, revolutions in manufacturing, and I do wonder, I'll be putting it to the panel whether, you know, we really are kind of seeing still a lot of 20th century manufacturing to address 21st century issues. And so what new kind of manufacturing and industrialization techniques are out there? What can we look forward to in the future? What kind of things are being developed? Are we looking at advanced materials, for instance, new production processes, biomaterials, for instance, the hot area at the moment? So hopefully we'll have a time to talk a little bit about all those. But also, what are the barriers? I mean, there's so much. I mean, here's my thought, but who cares what I think? I'm just the chair. But I think that we have everything in place now to solve the climate crisis. It's all there, but why isn't it being implemented? So what are the societal, the economic, the political barriers to these technologies that could save us from being implemented, or being implemented quickly enough? So that really sets the scene for what we're going to discuss today, and we're going to discuss it with these three excellent people that you see before you. So we've got to say hello first to Gbemi. So this is Dr. Gbemi Oluleye, who is assistant professor at the Centre for Environmental Policy at Imperial College, and you're actually very interested, Gbemi, in these barriers to manufacturers. You know, you'll be partly here to answer my question and my semi-rant about the text here. Why isn't it being implemented? And I'm relying on you to help us understand that a little bit better. But also, it's always interested to find other things out about the panelists. And one thing that I've just discovered from you, Gbemi, is that you are mad on cooking as well. You do like to cook, and you've been published for your cookery prowess. Can we say that?
Well, yes, I do. I do like to cook. I enjoy cooking, and I develop recipes for West African meals. Yes.
Wow. See, other facets to our speakers. I like finding these kinds of things out. So it's lovely to have Gbemi on the panel. We also have Miriam here. This is Dr. Miriam Ribul, who's a research fellow at in the materials. So in materials circularity for distributed manufacture, and I had to read that out. I do try and memorize the titles, but that's a bit of a mouthful. So I'll say it properly this time. Materials circularity for distributed manufacture, and you're at the Royal College of Art, so you're in the Materials Science Research Centre. And And you're interested in textiles, for instance, but other aspects and other aspects of materials. And actually, interestingly, one thing I found out about you, Miriam, is that you have worked in textiles, so you have some industrial experience as well as obviously what you're doing now at the Royal College of Art.
Yeah, I think, absolutely. I think understanding how the industry works and what really led me into research and thinking about new processes, new materials, new manufacturing, and specifically what systems need to be in place rather than the current production model that we know.
Yeah, absolutely. And that's a key thing, isn't it? Just the problematic production model that's obviously so ingrained and is going to take a bit of shifting, but we'll hear more about the challenges there as we go along. And also here in our midst is Dr. Rupert Cole, Associate Curator of Science at the Science Museum, and so you're very involved with Our Future Planet, the exhibition, which is on until September next year, isn't it?
Yeah,
So if you've not been to Our Future Planet yet, then you still have quite a while to get there, but don't leave it too late. So for people who perhaps haven't visited it so far, what is Our Future Planet?
So it's an exhibition all about carbon capture, utilisation and storage, and what role those kinds of technologies can play in mitigating the climate crisis.
Okay, and within the museum itself, you're very interested in the chemistry collections especially then, isn't it?
Yeah, so I've actually, since joining this panel, just moved on to a new role, but yeah, my full-time role is the chemistry collections, but I'm doing a secondment at the moment of all things contemporary science. So my remit at the moment is bringing, looking out for new technologies and scientific research, which we want to sort of bring to the Science Museum.
Okay, yep, so you've moved across and you've always been interested in all things sustainable, you were telling me then.
Yeah,
so.
Yeah, that's my key interest when I'm sort of researching science and technology and what we can add to the collection. Things which sort of speak to sustainability and the climate crisis and plastic pollution, those kind of environmental issues.
Okay, so it gets just talking about, oh, and by the way, as if anybody cares, but I'm Gareth, I'm the host, and I'm a broadcaster and lecturer, but enough about me, I'm just here to ask the questions, really, and occasionally be provocative. But let's talk, Rupert, then, about manufacturing, and perhaps you could start by saying what we'll find out at Our Future Planet, what that discusses about manufacturing.
Sure, yeah, so towards the end of the exhibition, we talk about how industries which will find it really hard to decarbonise, so concrete, steel, what can be done to try and mitigate their emissions. And one of the technologies that we showcase around this is solvents which are put in sort of factories and power plants to strip carbon dioxide directly from the emissions coming out of those factories. And then we kind of ask a question of, well, then what do we do with that carbon dioxide? So we showcase a range of different storage and utilisation technologies as well. And they range from concrete being injected with carbon dioxide to reduce its impact, as well as kind of more consumer products like anything like toothpaste. So we have toothpaste on display made from factory emissions. So it's kind of funny, if imagine brushing your teeth with factory emissions. Yeah, and lots of other kind of products like that.
Yeah, and we can see a few examples on the screen as well. We've learned a lot about carbon dioxide recently as well, haven't we, in this whole crisis, that it's been used in food packaging, for instance. So this whole carbon dioxide industry that I think very few of us have been aware of until these shortages that we've obviously become very aware of in the news. Gbemi, what about then, we heard about concrete and steel, the extent to which elements of our built environment, for instance, the materials that go into our everyday products and our built environment are carbon emitting, carbon absorbing, and then carbon emitting. So what else do we know about that?
Thank you, Gareth, for the question. So a lot of the energy-intensive industries that produce the fundamental materials we use in building, in transport, in iron and steel, in concrete and cement, they emit the most of the emissions if you look at the manufacturing sector. And it's probably because of the quantities that they produce and the energy they need. I'm going to ask if I understood the question.
Yeah, well, exactly. It was just expanding really what we heard from Rupert about the likes of concrete and steel being carbon intensive.
Yes.
And for, you know, I'd say what other materials, I mean, you can talk more about concrete as well possibly, but just other materials that we should be, and manufacturing processes that are carbon intensive, and the kinds of processes and materials that we need to focus on as part of our efforts to mitigate climate change.
All right, so I would say we need to focus on all manufacturing, but if we're looking at the energy intensive sector, so iron and steel refining, petrochemicals that produce the highest CO2 emissions in the industry, so those are the higher emitters, and the advantage of decarbonizing these higher emitters is you get to also decarbonize the middle chain. So if you decarbonize iron and steel production or refineries, that means that in our cars, in our homes, we're using clean products as the basic building material.
Yeah, and so you solve one problem, but also in a very, very virtuous way, you actually tackle a whole load of other problems down the engineering chain.
You tackle a lot of problems down the supply chain if you start from the big players.
Okay, well, let's delve into some of the alternatives then. And Miriam, what about distributed manufacturing? It's not a term I'm particularly aware of, but it sounds really interesting. So tell us about distributed manufacturing.
So distributed manufacturing is an approach that looks at more local and small-scale manufacturing, because I think if we listen to industries like steel and concrete, they're very large-scale industrial manufacturing processes, but they also have very high emissions due to the just mass-scale production of the industry that we know of. So distributed manufacturing, for example, has really good examples of thinking about how to produce locally, just small scale, and just adapt it to user needs rather than mass scale as well. So good examples of this, for example, thinking about design products as well. There's an industry company called OpenDesk, and they work with digital systems and local maker labs and send files that you can actually cut or laser cut or CNC cut with local tools, with local materials to build furniture or even prefabricated houses. So as one example. And then if you think about how to expand distributed manufacturing models, maybe we can also work, rather than with new materials, we can work with waste resources. So we can work with bio-based waste and a circular economy, local waste streams, local biomaterials, local skills, local tools, and local people. So we create kind of new networks that create new skills and new jobs, but also just manufacturing that is based on needs rather than on large scale. And another good example of that is Luma Atelier, for example, in the south of France. And then in the Textile Circularity Center at the Royal College of Art, we're also looking at local and distributed manufacturing, for example, how we can promote city-based manufacturing, so production that is in new spaces in the city, bringing biorefineries and developing new machines that enable more local and small-scale production as well.
Yeah, and of course there's a small scale, and yet it does seem as if with this approach, the economies of scale that we, I suppose, have given us all cheap products by, you have several very large facilities with production lines, and so you just get the cost down. It seems as if those benefits of economies of scale can also be mapped onto these distributed approaches then. Okay, so Rupert, what about carbon capture and storage? So this is related to manufacture, but we still need to think about the carbon that it comes, for instance, from concrete production, and sadly all the carbon in the atmosphere is the cause of the whole problem that we're having these discussions then. So there are technologies to take it out of the atmosphere.
Yeah, there are. So there's two broadly types of carbon capture technologies which are looking to capture carbon dioxide emissions. One is called direct air capture, which is the idea of actually sucking carbon dioxide directly from the air. So this is addressing the issue that even if we were to go down to net zero, there's still too much carbon dioxide already in the atmosphere. And then the kind of bit of that which relates to manufacturing is what you do to make use of that carbon dioxide that you've captured. So, and it actually addresses that issue you're talking about, scale. So at the moment, the only commercial direct air capture technology called Climeworks. Each unit, I think, sucks out something like 50 tons of carbon dioxide a year, but global emissions is 40 billion.
Okay.
So to put it in perspective, and the cost of their new facility has just gone up to, I think, £150 million, and that's with all the units together sucks out 8,000 tons a year. But at the moment, the cost of that carbon dioxide, for them to make that profitable, I think costs something like £1,000 a ton. Mm-hmm. So, and you can produce carbon dioxide as a byproduct of fertilizer from fossil fuels. So at the moment, there isn't a market economy to make captured carbon dioxide successful enough and economic enough to sort of drive, I guess, the commercialization that we need for carbon capture technology. So it does relate to manufacture.
Yeah, sure. And of course, my proposition at the beginning was that I reckon that the tech is already here the engineering is here to sort things out. It's going to be these sort of political barriers, social barriers, and many others that are blocked. Would that be right from what you see?
Yeah, I think it would need some kind of government intervention to incentivize it. But the other type I mentioned earlier, the capturing carbon dioxide at source, that's potentially another important area to focus on. Slightly different kinds of technologies, but they're kind of built into the architecture of power plants and manufacturing factories to try and, strip carbon dioxide to prevent it coming out in the first place.
Right, so Gbemi, lots of different ways of capturing the CO2 in the first place, so it doesn't become a problem further down the line.
Yeah, I mean, there are a plethora of ways to reduce CO2 emissions from industry. Most of them are incremental, which gets you to about 30% reduction in CO2, and then you have the very radical ones like CCUS and direct air capture. Yes, and it's about synthesizing all these various technologies. And like you rightly said, the technologies are there, albeit they are at different stages of development. So CCUS has been demonstrated, but it's not yet commercialized. So it's probably at the pre-commercial stage. Direct air capture, it has been demonstrated. It's still stuck at the pre-commercial stage. So at that stage, that's when you need a lot of interventions, policies from government, but also industries reinventing their business models to support these technologies at the pre-commercial stage so they get to the point where they are commercialized. Commercialized means that they are in the market, for instance.
Because it seems so far then that the manufacturers haven't been sufficiently incentivized to use all kinds of measures, including carbon capture, so they've been allowed to get away with it, haven't they, so far?
I wouldn't, the manufacturing sector has always been considered as a hard-to-abate sector, not necessarily to make them get away with the emissions, but because of the impact that it could have on society. Because if the manufacturing sector was forced to get to net zero, then to spread the costs, it will pass down to consumers. So you have an increase of cost. Another thing is what we call carbon leakage. So if the UK is the only country in the world that has a net zero carbon target for this sector, there is a fear that producers will move to other countries that have less climate targets. So it's been a sensitive issue for a while because they already operate on very low profit margins. But I think globally, most countries have signed up to net zero anyway. The advantage of that is it creates a market demand for clean technologies. So if we look at COP26 in November, if all the countries in the world sign up to net zero greenhouse gas by 2050 from all the sectors, that immediately creates a demand for CCS, that immediately creates a demand for direct air capture. And because the political climate is correct, that means investors, producers can take a risk to put money down, and an increase in demand will lead to a reduction in cost since the technologies have been tested at scale.
Yeah, and I certainly think one of the successes that came out of the Paris COP was it seemed like that, to me, seemed to be the moment that the business community really thought, actually, we can do this green and we can make money out of it. There became a business case for it, and I wonder if that was partly behind some of the progress from Paris. Many would say not enough progress, but progress nonetheless. Miriam, what about you? Not that we're going to go sector by sector, but you know a lot about textiles and that kind of manufacture. And I heard earlier on a statistic I hadn't been aware of, which is that the fashion industry and clothing, they account for 10% of carbon emissions, way more than I'd thought of. So what is it about textiles, clothing and fashion that's just so carbon intensive?
I think that the quote is correct. I think it's combined, the apparel and footwear sector is about over 8%, and it's combined like with aviation, international aviation, and transport, I think, as well. So I think it's, well, there's an issue we definitely know is with scale and mass production that we know of. And for that reason, thinking about smaller distributed approaches is one approach. I think there's a lot of things that we can learn from the textiles and fashion industry as well to apply that to manufacturing and specifically in the circular economy, because if we think about rather than producing a lot of new clothing like we're currently doing and a lot of new items, and that was also increases the carbon emission of all the sectors in particular. We can think about more strategies of how we maintain materials for longer, we maintain textiles, we find new circular resources as well. So there's kind of different approaches which we can apply to the textile sector, but there's definitely a big requirement for change, which is connected to the fast fashion model and all the high consumption models that we know of.
Yeah, no, exactly. And it does seem as if there are so many ideas from fashion, like you say, the circular economy, say renting clothes, more at the high end aspects of fashion, but nonetheless, people can rent their wardrobes, and even like clothes swapping apps as well. So, if somebody wants to wear this jacket for a week, as if they want to really, but imagine if they did, there are good of apps that I might be able to go to where I can swap this jacket with somebody for a week, and then maybe Rupert could lend me a shirt or something, I don't know. It just seems that sector, and maybe just the people who are customers of that sector have been very innovative. And you're saying that, that we can learn from all these different circular economy techniques. Do you mean for things like automotive, for instance, or for personal tech, consumer electronics, just across the board? Are there lessons to learn?
Yes, I think absolutely, because we know how to repair our electronics, for example. Electronics are being repaired in some cases, hopefully, more than, for example, textiles and clothing. So if we can think about maintenance of materials, maintenance of infrastructure, maintenance of buildings, different, instead of using manufacturing technologies, for example, into new contexts. So, for example, thinking about restoration, and I think a good example of how to think about that across sectors is how to restore biodiversity, how to restore water, how to avoid waste. And that's something that I think is universal. It doesn't only apply to textiles and fashion. And at the same time, that's one approach.
And yet aspects of the consumer electronics industry just seem to be really guilty of this throwaway culture. And I'll name and shame, I've got an iPhone, and earlier this year, when the battery life just gets absolutely rubbish and you have to take a charger thing around with you all day, otherwise it just goes like that. And I thought, my first reaction was to get a new iPhone. I thought, right, and then I looked at the prices and I thought, I'm not spending that amount of money. So then, obviously, there are loads of places you can get second-hand iPhones, but even they're really expensive. So I nearly got one of those, and in the end I thought, well, I'll just change the battery. How hard can it be? And I found actually it is quite hard. It's and I have a degree in electronics, by the way, folks. And probably a load of you have seen this as well. You can get these kits, which I ended up doing, for about £20, just a kit that had the new battery in it and a load of tools that allowed you to dismantle your iPhone. But it's just taking the old battery out was a real pain because it really stuck to the frame of the phone. So that, I don't know what the panel think of this, whether you're able to name industries where some are just terrible with the circular economy and really need to rethink their model, and others, maybe like fashion, which is kind of getting a bit better, where the model is a bit better. So I've named and shamed consumer electronics, but Rupert or any of you, Are there industries that you can think of, or sectors that are equally villainous, or a few heroes out there?
Well, the one which comes to my mind always is the plastics industry, which is continually churning out new fossil fuel petrochemical plastics when we've got plenty on the planet which we can make use of already. But it's a massive challenge, I think, particularly when you think of consumer products, recycling plastics. So technology I've been quite interested in is chemical recycling. So what do you do with all the plastics like crisp packets and films and polymers which are multi-layered, which can't actually be recycled at all? This new technology, chemical recycling, is an aim. It sort of breaks down those polymers into gases, then sort of distills them back into oils to make new plastics. But there are problems with that approach, such as you don't always get food-grade plastics, which is where lots of this single-use plastic problem is. It's in food packaging.
Yeah, and we all want nice fresh food from the supermarket.
Yeah.
Okay. So, Gbemi, I mentioned that you were going to take us through what some of the barriers are, because it does seem as if the chemical engineers have worked a load of this stuff out. So why isn't it happening more?
So there are different levels of recycling that goes on in the chemical industry. So if I take plastic manufacturing, in the manufacturing plant, there is a recycling that goes in to take any byproduct back into the process. So that's the first level, that it's on the ground, it's easy to implement, it has been implemented for years. There is another level of recycling that comes with used products, which is what Rupert mentioned. The technology is there, however, most times it's energy intensive, because you're breaking down the bonds in an existing model, in an existing plastic, and you're putting in more energy than you're getting out. So it's a decision that needs to be made. You put in more energy to get a new product out of a recycled product, or do you just produce from scratch? Now, 10 years ago, it was the case was there, the business case was there to just produce from scratch and encourage consumers to reuse plastics or reduce the demand for new plastics. But I think where we are now and where we need to be looking at our carbon budgets, the decision has tilted a bit to recycle or find an alternative raw material for making plastics, so bioplastics, for instance. Of course, the business case, if you look at the economics, is high, but if you look at the value, it's better to move to bioplastic. Now, circular economy is supported by recycling, but one of the things that we are pushing for is to encourage people to use plastics for a longer time. But like you rightly said, the technology is there. It is energy intensive, but it's sourcing the energy from clean sources. That's the goal going forward. Making sure we are channeling the use of green hydrogen or blue hydrogen or renewable energy to drive that process to make new plastic from recycled materials. And also a bit of industrial decarbonization it's becoming more topical is behavioral change. I was looking at a supermarket in Thailand where they use banana leaves.
Banana leaves?
Yeah, to package fresh food from supermarket instead of food-grade plastic, so just put in banana leaves. So in the UK, for instance, now we pay for plastic bags. So there's some behavioral change going on to reduce the demand for plastics.
Yeah. Excellent. And we'll go to you for a few questions in a second. Let's just take an online one. This is from Gemma, who's watching online. Gemma says, plastic bottles seem to be a big polluter of the environment. Can these plastics be recycled into a substitute building material or be transformed into something safer for the environment? I'd have thought they could, couldn't they?
Yeah, there's actually some initiatives that's already doing that, not just bottles, but compressing waste plastics down for construction materials. I've seen some projects that do that in the UK, but also in lots of other countries. But funny they mentioned bottles, because PET bottles are one of the most easily recyclable of all plastic products.
Didn't realise that. Okay. Oh, that's encouraging. And Gbemi, were you going to say something as well?
I was going to say,
Rupert said it. Okay.
Yeah, that
all right.
I think globally plastics is a big issue. So I saw a documentary from Nigeria actually where they use recycled plastic bottles to make handbags. So there's a lot of work going on in that area.
I think a lot of this is just being more imaginative, really, isn't it? Like, hey, let's package our food with banana leaves, just that kind of thinking. And some of it will work, a load of it will just go horribly wrong, but at least it's better than just sticking with the existing and not very sustainable ways of doing things. All right, shall we take some from the audience? Put your hand up if you fancy having a go. Yeah, okay, it's Francesca, isn't it? Yay, excellent, hi again, yeah. So, yeah, come up to the mic there, Francesca, and I know it's a faff, but it means everyone at home can hear what's going on in the hall.
Thank you, panel. It's an absolutely fascinating discussion. One of the things, a question I'm really excited to ask, and it kind of touches on some points that have been raised about synergies, working with waste resources. This tackles directly the circular economy, I believe, restoration, avoiding waste, consumer electronics, and that is. I've heard, I watched a documentary about 3 years ago about mining landfill because of the amount of resources that exist there. And with the sort of the huge controversy around deep sea mining, I just wondered what the panel thought on that. But it's such a tricky area because you've got the exploration of the deep sea funding the research to see how valuable those ecosystems, well, of course they're valuable, but to see how they implement and affect our day-to-day life. But I'd just love to hear what the panel thinks about, mining landfill and how that could benefit us and maybe take away, if you think, the need to deep sea mine. Thank you so much.
Yeah, cheers, Francesca. Mining landfill, Miriam.
So I think that's something we're actually doing at the moment in terms of the Textile Circularity Center, because we're working with circularity and circular economy. We're actually looking at not so much mining landfill, but looking at avoiding landfill altogether. And currently we have about 1 million of clothing being discarded, either incinerated or in landfill a year in the UK. We have about 7 million organic fraction of municipal waste in the UK, which is, for example, food waste and contaminated food packaging, and that's mostly being incinerated. And we also have huge scale, I think it's about 12 million just of wheat straw, so like agricultural crop waste, which is about 16 million, I think, production. So if we take all these waste streams and we look at it from, for example, a green chemistry or material science perspective, they all consist of highly valuable polymers, which we can use for textiles or different industries, for example, and that would avoid landfill altogether. So that's about thinking away from the waste concept itself. And that then can also be a new feedstock that is then introduced in the circular economy into a new system. So it requires a full approach. It requires thinking of a supply chain. It requires thinking about new processes sustainable for production, and also that we keep these resources in a closed loop. So it's actually a quite nice example thinking about the plastic bottle and plastic waste. There's always an aim to, for example, in a lot of industry, find bio-based alternative materials in that context as well. But then if we don't have the correct recycling system, it might land in landfill and then might have methane emissions as well and might actually contribute to. So there's a lot of miscommunication around materials and their life cycles and what can happen with that. So I think landfill is a huge resource which we could mine for electronic waste. All electronic waste has plenty of very high valuable materials in there, and if products are designed with planned obsolescence that they can't be repaired, we could actually theoretically mine our waste for precious metals, and then we don't need to use new metals, we don't need to use new materials, we don't need to grow materials, we don't need to cut trees. It's a huge benefit to that, so thank you for that. Question.
Yeah, great question. I must say, I'd never heard of landfill mining, so I'm learning all the time. This is my 8th panel this weekend. I've just learned so much. My brain's getting huge. By the way, folks, at home, thanks for watching at home, but do send any questions you have. Just put them in the chat, and the moderators will send them through to this, but I won't try taking the battery out, I promise. All right. So shall we talk a bit about materials? I know we've talked a little bit about banana leaves and also materials derived from recycled products. But what else is out there? 'Cause they must have lots of names like nano this or graphene that and other fancy things. So do anything spring to mind for our panel, new materials that we can get enthused about? Or have we done them all? No? Okay.
Hello.
Don't be shy.
I guess I would want to go back to that, developing new materials from waste. And I had a really interesting chat this week with a company based in Scotland called Cuan Tech. And Cuan, I learned this week, is it means oceans in Gaelic. And they are making use, so crustacean food, so crabs, lobsters, langoustines, 50% of it just goes to waste into landfill. And they're working on technologies to derive a polymer from the shell itself to produce new plastics. And this is both bio-based and key biodegradable. And there's a lot of difficulty around biodegradable plastics contaminating waste streams, for example. But this is a really interesting one because the polymer is chitin. It can actually go back in the ocean and be a food source in the ocean. So it's a new kind of potential plastic, which is, nature-derived, but also has a unproblematic, I guess, end of cycle.
Okay, well that's again not one I'd heard of. Yeah. So and Gbemi's nodding there as well.
Yeah, I heard about it. Again, the challenge is they are not produced at scale to make a big difference. But there's a lot of work going on in biodegradable materials made from biosources. I mean, biotechnology in the UK is very strong. Looking for alternative materials to everything that currently exists. There is an alternative. I discovered I just discovered recently that there is an alternative for concrete. Again, is the scale at which it's been manufactured. Most of them have a very low technology readiness level, so some of them are still being pilot tested.
Yeah, that's cool. And also, Gbemi, whilst we're chatting then, because part of your research area is the role of governments in all this, in driving things. And we've spoken a bit about it in this panel so far, but are they doing enough to really get behind these new technologies to create incentives? Could they go further?
So I can talk for the manufacturing sector. So when we did the economic analysis to see how much you need to invest to get the manufacturing sector to net zero, it's a lot of money. Even for government, it's a lot of money because there are other things that need government attention. There is health. So what I've done is to create a roadmap where government plays a role by enacting policies that can steer the market. So if I use UK as an example, so the Prime Minister's 10-point plan was a way to kickstart the market, but also make promises to support the push of technologies past the demonstration stage and also the demand pool for these new products. So can government do enough is a question. Also, there's a lot to be done. I think what government can do that will be enough is to make the right decisions in terms of a mix of policies, in terms of regulations, in terms of mandates, in terms of incentives that can support early adopters, because this is the way we see the trend. If you have the right mandate, for instance, net zero carbon target by 2050, if you have the right incentives to support research and development, to support people driving electric cars, for instance, or in homes, you've got the renewable heat incentives, which supports integration of heat pumps, and for commercial businesses, you've got the non-renewable heat incentives. So that means for it's no.
I hear noises. Oh no. It's the fire alarm. Okay. So at this stage, the stewards will escort us out. That was a shame. Halfway through something very interesting there. So.
Oh.
Okay. Thank you. Thanks for coming. Well, hopefully we can restart.